In 2017, a German research team extracted genetic material from 151 ancient Egyptian mummies, expecting to confirm what every textbook had taught for a century. But when the sequencing data came back, the ancient Egyptians showed almost no genetic connection to the modern population living along the Nile today, and the closest match pointed to a group nobody expected. For thousands of years, we assumed the people who built the pyramids passed their bloodline directly to the Egyptians of today, but the ancient deoxyribonucleic acid evidence tells a completely different story, one that historians are still struggling to explain. This video breaks down the actual peer-reviewed findings from the Max Planck Institute study, every claim sourced, every conclusion grounded in published research. So before we go deeper, hit that subscribe button, because this is the kind of evidence-based science you will not find anywhere else. To understand why this discovery shook the academic world, you need to picture exactly what the researchers were trying to do. The team, led by Verena Schwinnemann and Johannes Kraus from the Max Planck Institute for the Science of Human History, traveled to the archaeological site of Abusir el-Meleq, an ancient settlement located about 100 kilometers south of Cairo. This site held a cemetery used continuously for more than 1,300 years, from around 1400 before the Common Era, all the way to 400 of the Common Era. That timeline is crucial because it covers the late New Kingdom period, the entire Greco-Roman period, and the early years of Christian Egypt. The researchers wanted to see whether the people buried in this cemetery changed genetically over those 13, and whether they matched the Egyptians living in the same region today. The methodology was extraordinary. Ancient deoxyribonucleic acid is incredibly fragile, and in the hot, humid Egyptian climate, genetic material was supposed to degrade beyond any chance of recovery. For decades, scientists believed mummy genetics could never be reliably sequenced. But the Max Planck team developed a new extraction technique that targeted the petrous bone, the densest bone in the human skull located near the inner ear. This bone preserves genetic material far better than teeth, hair, or soft tissue. Using this method, they successfully recovered complete mitochondrial genomes from 90 mummies and full nuclear genetic data from 3, marking the first time scientists had ever produced high-quality genome-wide data from ancient Egyptians. Now here is where the results stopped making sense for the researchers. When they compared the ancient Egyptian genomes to populations from across Africa, the Middle East, and Europe, the closest genetic match was not what anyone predicted. The ancient Egyptians showed the strongest similarity to populations from the ancient Near East, specifically groups from regions corresponding to modern Israel, Lebanon, Jordan, and Syria. They also showed substantial genetic affinity to Neolithic populations from Anatolia and even certain European groups. What they did not show was a strong connection to sub-Saharan African populations, which directly contradicted what many scholars had assumed for decades. The truly shocking finding came when researchers compared these ancient genomes to modern Egyptians. The connection that should have been there was much weaker than expected. Modern Egyptians carry roughly 8% more sub-Saharan African ancestry than the ancient Egyptians from Abusir, el-Meleq did. That number sounds small until you understand what it means. It means that after the fall of pharaonic Egypt, after the Roman conquest, after the Arab invasions of the 7th century of the Common Era, the Egyptian gene pool was significantly reshaped by population movements that brought new genetic material into the people who built the pyramids were not the direct ancestors of most modern Egyptians in the way historians once assumed. If the ancient Egyptians were genetically closer to populations of the ancient Near East, what does this tell us about how Egyptian civilization actually formed? The answer pulls together threads from archaeology, linguistics, and now genetics into a single coherent story. The Nile Valley was not an isolated bubble. It was deeply connected to the broader cultural sphere of the Eastern Mediterranean and the Levant. Trade routes ran constantly between Egypt, Canaan, Mesopotamia, and Anatolia. Egyptian language itself, part of the Afro-Asiatic family, has roots that connect to languages spoken across the Near East. The genetic evidence simply confirms what trade records and linguistic analysis had already hinted at, that ancient Egypt was woven into a much wider regional tapestry than the popular image of an isolated desert kingdom suggests. The genetic stability across 13 centuries is another part of this story that deserves attention. Despite Persian conquests, Greek occupation under the Ptolemies, and Roman rule, the genetic profile of the people buried at Abusir el-Meleq remained remarkably consistent. This suggests that even when foreign rulers controlled Egypt politically, the actual population on the ground did not undergo dramatic replacement. The genetic shift toward more sub-Saharan African ancestry came later, primarily after the Islamic period began in 641 of the Common Era. The trans-Saharan slave trade, which transported millions of people across the desert over more than 1,000 years, played a major role in reshaping the Egyptian gene pool into what we see today. Now let us turn to where this discovery becomes financially significant, because findings like these are reshaping major industries in ways most people never see. The global consumer genetic testing market reached approximately $3 billion in 2024 and is projected to surpass $12 billion by 2030, growing at an annual rate exceeding 15%. Companies like Ancestry.com, 23andMe, and MyHeritage have built business models around helping customers trace their ethnic origins, but the accuracy of those reports depends entirely on reference databases. When studies like the Max Planck research demonstrate that ancient populations differed significantly from their modern, the entire reference framework for ancestry testing has to be updated. This costs companies tens of millions of dollars in research investment, but also opens new revenue streams as customers pay for upgraded analysis. The pharmaceutical industry has even more at stake. Drug responses vary significantly between populations because of genetic differences in how the body metabolizes. The cytochrome P450 enzyme system, which processes about 75% of all prescription medications, shows substantial variation between populations of different genetic ancestry. Pharmaceutical companies have historically conducted clinical trials, primarily on populations of European descent, which created a massive blind spot. Drugs that work effectively in one population may produce different results, or even dangerous side effects in another. The personalized medicine market, valued at approximately $593 billion globally in 2024, is now investing heavily in population-specific genetic research, with major players like Pfizer, Roche, and Novartis establishing dedicated divisions focused on ancestry-informed drug development. The biotechnology sector has identified ancient genetic research as a major growth area. Companies specializing in advanced sequencing technology, like Illumina and Pacific Biosciences, have seen demand surge from both academic institutions and private investors. Illumina alone reported revenue of $4.5 billion in 2023, with a substantial portion coming from ancient genetic material analysis equipment. Venture capital firms have poured more than $2 billion into biotech startups focused on ancestry genetics over the past 5 years. The bet these investors are making is straightforward. As more ancient populations are sequenced and more genetic differences are documented, the demand for personalized health products, ancestry verification services, and population-specific medicines will only grow. The Egyptian study and others like it are not just academic publications. They are signals to global capital markets about where the next wave of medical and consumer technology profits will come from. The story of ancient Egyptian genetics is more than a chapter in a biology journal. It is a window into how knowledge itself evolves. For more than 2,000 years, scholars relied on inscriptions and ancient writings to understand who the Egyptians were. Then a single research team, armed with new extraction techniques, fundamentally changed that picture in less than 5 years. This is how science works at its best, not by confirming what we already believe, but by forcing us to confront evidence that does not fit our expectations. If this investigation expanded the way you think about ancient history, support the channel by hitting that subscribe button and turning on notifications, because every newly sequenced genome brings us closer to understanding who we really are. Drop a comment below sharing which discovery surprised you most, and tell us which ancient civilization you want investigated next. Share this video with someone who loves real science instead of internet myths, and remember, on this channel every claim is sourced and every conclusion grounded in peer-reviewed research.